Alright, we're going to be rewriting logarithmic equations in exponential form, and it's very simple. I'm just moving a few things around. Now when you do these, you're going to have a log with a base. So in this first example, we've got a log base of 9. So whatever your log base is, when I write this in exponential form, that log base is going to become the base of an exponent. And my exponent, I'm going to get that from the equation right here. I'm going to switch these two numbers. So the answer over here, this 2 that was the answer, is going to become my exponent. And my exponent over here is going to become the answer. And you'll notice these make true statements, like 9 squared, it equals 81. And same thing over here in this second example. I have log base 8. This base right here becomes the base of an exponent. I'm just going to take this log base 8. It's going to become 8 to some power. And I get that power by switching these two numbers around. This answer 2 becomes my exponent. So this would be 8 squared. And my answer is going to be whatever the exponent was to this log base. So 8 squared is 64. And you'll always rearrange it like this. So whatever your log base is, that becomes the base of your exponent. And I'm just going to simply switch the two numbers right here. Okay. And sometimes it looks a little weird. Like you'll see in this example, we've got log base 2. I'm not going to do anything different. That becomes the base. And I'm going to switch these two numbers. Now having a 0 doesn't change anything. I'm still going to use that as my exponent. And anything to the 0 power is going to give me an answer of 1. So anytime you have 0 as an exponent, your answer, no matter what that number is going to be 1. And you will also see fractions. And I'm going to treat those exactly the same way. They just follow the rules of exponents. So let's say I have a log base 2 here. I'm going to treat it the exact same way. It's going to be the base of an exponent. And I'm simply going to switch the order of these two. Now that gives me a -6 as my exponent. But that's okay. When you have a negative exponent, it's going to give you an answer that is a fraction. And when I switch those two, that's what happens. I get 2 to the -6 power gives me 1 over 64. So don't worry about what it looks like. It's always going to follow the same steps. And you may have times where you get fractions as exponents, and that's okay too. I may get, for example, I may have 81. This is my base, and I'm going to switch these two, and that's going to give me a fraction as an exponent. It's going to give me 1/2 as my exponent, and I'm switching those two, and my answer is going to be 9. So you'll notice when you have a fraction as an exponent, you got 81 to the 1/2, it gives you a smaller answer, and that's what fractions do. When I take a fraction, like 9 squared gives me 81. Well, 81 to the 1/2 is going to give me something smaller. It's going to basically take the square root of that. But fractions just give you smaller numbers, and it's okay. You still rewrite this the exact same way, no matter what numbers they give you, fractions, whole numbers, or whatever. So it's pretty simple. And we're going to need this when we start solving equations. And we're going to be looking at some equations that require us to use logarithms when we're solving them. All right, for example, you will see exponential equations that are going to require us to use logarithms. And in this example here, you can see that we're going to kind of go backwards from what we were doing. You know, we had a log base and we made it the base of an exponent. Well, here I have a base, and what I'm going to do with that is I'm going to take this base right here, this 14, and I'm going to make it the base of a logarithm. So I'm kind of going backwards from what we were doing earlier. So this becomes log base 14. But just like we did before, I'm going to switch these. Now that I'm going back into a logarithm, this would become log base 14 to the 78. I'm going to take this number here. The answer becomes basically the exponent here to this log base. And I'm going to switch to where the 4n, that was the exponent, it becomes the answer. Now we're solving these equations. So what I want to do is, just like with any equation, I'm going to get the variable by itself. So here I have 4n over here. I'm going to get rid of this 4 times n by dividing by 4. And look at it just like an equation. Once you have it set up, solve for the variable. This 4 would cancel out over here, but I'm going to divide both sides of the equation by 4, and this is my answer. This is what the answer would look like. It would look like a fraction. All right, I would just leave my answer like this. I canceled out the 4. Now it is solved for n. And then no matter what they're asking us to do, we're just going to follow the same steps every time. This base to the exponent, this 15 right here, would become the base to my logarithm. So this would be log base 15. And I would switch these two around so that this 47 that was the answer right here becomes the exponent. And this a plus 2 moves over here and becomes the answer. And just like before, I'm going to look at the variable, figure out what's being done to that variable, and I have a plus 2 here. I'm going to get rid of that by subtracting 2, just like I would with any other equation. All right, now these are not like terms. I can't subtract 2 from this, log base 15 over here. So I'm going to write this out as log base 15 to the 47th minus 2. I already got rid of the 2 over here, so my equation is essentially solved for the variable. And that is it. And the initial steps are always going to look virtually the same no matter what we're doing here. In every logarithm, we're just following the same steps. We're rewriting these exponential equations, writing them as logarithms. Okay, so steps will always be pretty much exactly the same every single time. I will always take this base to my exponent. It becomes the base to my logarithm. So this would become log base 16. And I'm going to switch these numbers every time. So this becomes log base 16 to the 96 equals, and when I put the k minus 10 over here, I've got a one-step equation, and I'm just going to solve for k and do whatever I need to do to solve this equation. So here I would just add the 10 to get rid of the minus 10. I would add this to both sides. Just don't get confused and try to add the 10 to the 96 or anything like that. These are not like terms, so I'm going to leave them separate. I've got log base 16 to the 96, and I'm adding this 10. I'm not going to add it to the 96. I'm just going to have this plus 10 over here to the right. It is not a like term. I'm not going to add it to that 96. So it's just going to be over here kind of off to the right. So don't add 96 to 10 and get 106. I'm just going to leave them separate. These are not like terms. That's what my final answer is going to look like. Okay, and always follow those same steps. Whatever the base to the exponent is, that's always going to become the base to my logarithm. So if it was a 3, for example, here, it just becomes log base 3. Switch these two numbers and do whatever you have to do to get your variable by itself. So if it was multiply, to get that variable by itself, I would divide, and I'll get an answer that looks like a fraction. So just, as long as we stick to the same steps and we just solve for the variable, that's pretty much all we have to do to solve these equations.